Yo, what's up? Let me check. Is this working? I think I need to reduce the volume a little bit. I think this should be good. Let me quickly check my live stream. Okay. Let me quickly check my live stream. Hello. Let me quickly check my live stream. Hello. Yes. Okay. Okay. The same microphone. Let me quickly check my live stream. Hello. Yeah, this should be better. Okay. Okay. The same microphone. Let me quickly check my live stream. Hello. Yeah, this should be better. Okay. The same microphone. Let me quickly check my live stream. Okay. So. Yeah, this should be better. So. Yeah, this should be better. Alright, my stream's configured. So what are we doing in this video? Well, if you read the title correctly, then you should be knowing we're going to be implementing binary and linear search algorithms using recursion in Python. This has been covered very well in the internet, but I'm going to also be doing this for strings, not just lists of numbers. So that's basically the entirety of the stream. Anyway, let's get started. Okay, so first let me quickly put a comment. Binary search using Python with recursion. So how does binary search work? Okay, so let's take a string, right, or rather a list of numbers like this. Alright, now the aim of the algorithm is to find a certain number, a target number within the list, and return the index position within that list. Okay, now there needs to be a few requirements for binary search to work. One thing is it has to be a sorted list, that is to say it should be ascending. Another requirement is that the for the algorithm to work is that there should not be any repeating values. That's basically it. Okay, now that we have this ready, we need to basically think of how the algorithm works. So let's say we want a target value of 5. Okay, so the way this works is it is a divide and conquer algorithm. It divides the big list we have over here. Let me quickly. Okay, it divides this big list into two smaller sublists. How does it do that? Well, basically it takes the higher and or the highest and lowest value within the list and finds the middle value. So what's the highest and lowest value within the list, or rather the index positions? So how do you specify highest index and lowest index positions? So that would be 0 and 5, right? Alright, 0 and 4. So now what it does is it adds them together. So 0 plus 4 and divided by 2 gives you the index position 2. Now what it does is it compares the index position returned to the target value. So we wanted a target value of 5, right? So now that it does match, it basically returns that index position. Let's say it doesn't match. Okay, this is assuming that the middle value is what we want. Let's say we wanted 9 or rather 7, why not? So what does it do? Basically it compares, as I said before, it compares the index position returned to the target value. If it isn't, then it tries to check whether the middle value, which is basically what we got here. So index position return is just the middle value. Okay, checks whether the middle value is greater or lesser than the target value. Okay, so within that index position it finds out whether the value is greater or lesser. In this case 7 is greater. So now that 7 is greater, what it does is it creates a sublist. So it does recursion within the same list, but then it creates a sublist wherein only these values are present. So now what we have is just, okay, we have is just 5, 7, 9. Alright, so within 5, 7 and 9, what it does is it adds the two index positions together. So the highest and lowest index position, so 0 and 2, and what it does is it divides them by 2, so what we get is 1, and it compares the middle value to that what do you say, that will compares the middle value which we just got to the target value, which is 7. So we did get 7, so that means it returns the index position of 7. You get my point? If it is 9, again it does recursion, alright, but in this case 7 would be the middle value, and if we wanted 9, then 9 would be greater than 7, so it creates another sublist of just 9. Okay, so now what happens is the highest and lowest value both are 0. When divided by 2, it gives you 0, so the index position would be 0. But then we'll be thinking, why doesn't it just return 0? Well, that's the thing, right? It doesn't create a new sublist as you think, right? It doesn't create a sublist. It checks within the sublist, but the original list is still maintained. So the original list here will still be maintained. This is just for reference. It doesn't create it. So now the index position will obviously be 5 or rather 4 for 9, because if there are no sublists being created, it just basically compares the values towards the right side, which is probably greater than the middle value, assuming that it is sorted. To put it simply, okay, if you didn't get it, if it is greater, it takes the values that are greater than the middle value, then within that greater values, again it checks within the middle with the middle value whether what we want is the target value. Okay, it is not the target value. Again it tries to check if the middle value within that is greater than the target value. So you get my point. The same thing happens with values less than that, so we wanted 3, so it takes all the values from 3 or rather below 5. So now that we have this sorted out, we need to think of what are the stuff we need to implement the algorithm, right? So we need a few things, right? We need the list itself. Let's just put requirements. So we need a few things. We need a list, we need the highest value or highest index position, lowest index position. Okay, let's see what else we need the target value, obviously, so we need the target value, and we need the middle value. But when we're implementing this in function, I don't think we need to be needing the middle value, because we can just do it with the function. So we need these. We need the list, the highest index position, lowest index position, and the target value. Okay, let's start implementing. So define binary search list high, low, target, right? Now this only works, right, if the higher value is greater than or equal to the lower value, right? Because if lower value is greater than higher value, how the hell is the algorithm going to work? It doesn't make sense. Alright, so now that we have that, we need to start implementing the middle values. So middle, right, is equal to low plus high divided by 2. Actually, let's see. Yep, that's it. Alright, next we have the highest index, we have the lowest index, so we can just jump right into the implementation. So if list x middle is equal to target value, return value searched it is present at index and then middle. Alright, now we have the recursion bit, which is a bit confusing for most people, I guess. So else return, and then we just recurse over the same thing, right? Actually no, there's a certain thing to implement here. Okay, so we told before that it compares the highest and compares the middle value to the target value, check whether the middle value is greater or lesser than the middle value, right? So we have to include two elifs. Elif list x middle is greater than target, right? And we also have to implement elif list x middle less than target, right? If the middle value is greater than the target value or the middle value is lesser than the target value. So now basically we have to return two things, right? We obviously have to return binary search in the same list. Okay, here we need to look at what is the highest and lowest values. This is a bit tricky, I guess, but once you get the hang of it, you'll understand it. Alright, so let's take this. Let's take 5 as our middle value, or rather, let's take 7. So first it checks with 5, but then 7 is the target value we want. So if this is middle, we need to check with values that are greater than middle. So now the new low would be middle plus 1, the index position of middle plus 1, and then the new high would be the index position of 9, which we can get by just doing length of list minus 1. It makes sense, right? The length of the list would be 5, the index positions would be 4 because it starts indexing at 4. So in this case, the new high would be index. So this is assuming the index position is greater than target. Okay, so let's say the middle value is greater than target. So now the new high, or rather the new low would be middle minus 1. No, I'm sorry. The new low would be the position 0. It would be the same. The new high would be middle minus 1. Makes sense, right? It's all the values except for the middle value. So in this case, now that the middle value is greater than target, the highest value would be middle minus 1. The lowest value would be sorry, would be 0, right? And target value will just be the target value. In this case, actually, we just gave this as low itself. In this case, the high value will remain the same, right? But the new the new low would be middle plus 1. Sorry about that. Alright, else return error. So yeah, what the hell. So yeah, that's about it. That's basically the binary search algorithm. Now let's take a list, right? List 1 equals, let's put haphazard values. So 2, 5, 1, 3, 5, 7, 6, 8. Right. Clearly this isn't sorted. And is there any repeating values? 1, 2, 3, 4, 5, 6, 7, 8. No. So let's sort this list. So list 1 equals sorted list 1. So now if we print this out, right? Now we get the sorted list 1, 2, 3, 4, 5, 6, 7, 8. Now let's do the binary search. We'll do print binary search, and then the list. So list 1, the highest value, so the length of list 1 minus 1, lowest value which will just be 0, and the target value, which let's take the target value as 8. Why not? Alright, so ideally the index position, since 8 is the highest value, would be 7, right? So let's check. Okay. Oh, this is a weird concatenation thing. Let's just do string middle. This should fix it. Wait. Value searched, it is present at index 7. 0, 1, 2, 3, 4, 5, 6, 7. That's right. Let's try for 1. Index 0. That's true. Let's try for 5. Huh, interesting. Maximum recursion depth exceeded in comparison. Okay. Well, as calling the error, it's so this, suppose there is an infinite recursion happening. If it's happening at line 46, line 39. Okay, so let's see, what's the problem? Maybe we need to do this. Oh, interesting. Okay, so what I did here was just basically the highest value would be the value. So the middle value is just the low plus the highest value, right? The highest value would just be high minus low, right? I guess that makes sense. Let me explain. Let's say the list is like this, right? 1, 3, 4. So obviously the lowest index position within this would be lowest index is 0, right? Highest index would be, right, it would be the So as I said, high would be the length of the list minus 1. So it will be 7 minus 0. So you might be wondering, why can't we just keep 7, right? Why can't we just keep the highest value? Well, if you do the middle value, right, so that will become, let's see, 0 plus 7 divided by 2. Okay, so in this case 2 times 3 will become 6. Okay, oh wait, I'm taking the wrong thing. The highest index in this would be 3, right? So that'll just give you the index position 1, but then the so the problem with that is because that wouldn't exactly be the middle value. We need a value higher than, so for even numbers we need a value higher than this, right? Because what will happen is, if the target value is greater, actually no, it should be working. I'm a bit confused. Let me try it this way. Yeah, see, that makes sense. Nope, there's nothing to explain. It's just, I think, stupid indentation. Okay. So let's try for 4. Value position index position 3, 0, 1, 2, 3. That's right. Let's try for index position 2. Present index 1. So that's basically it. Let me put end equal to /n. That's weird. I guess separate is it? No. Oh wait, I can just do this. Yeah. So yeah, that's basically it. That's binary search. Now that we have finished that, let's move on to linear search. Alright. So let's keep the list one as it is. Let's take this sorted list and move away. I think I should include this in paste then. Okay. Linear search with Python. I'll also later show you guys how we can use this for strings. Alright, because it does work for strings. Is that the for the algorithm to work is that there should not. Okay. Alright, let's get started. So let me just quickly do one thing. Yeah, this should be better, right? Should I speak closer to my microphone like this? I guess that does make a difference. Okay, I guess this should be better. Okay, so linear search. How does this work? Let's take this list itself. Okay, let's take this list. 1, 2, 3, 4. We need a sorted list. So the same things apply here. So we don't want repeated values, plus we don't want unsorted list. So no repeated values and unsorted lists. Now that we have covered that, the way it works is quite simple. Okay, so if we have a target value, let's say 3. So what it does is, it goes index by index by index and checks whether it matches with the target value. So is 1 matching, or is index position 0 matching with the target value? No. Move to the next one. Is index position 1 matching with the target value? No. Move to the next one. Is index position 2 matching with the target value? Yes. Return 2. So that's how it works. 8. So the implementation is pretty simple. We need the list, obviously. We need a target value. But here the key thing is, we need two key things. We need the highest value and we need the counter. What does this counter do? How does this recursion algorithm know when to stop and when to go to the next index position? That's what the highest and counter values do. Basically, the counter value will go from the 0 index position, get appended by 1, so 1 index position, get appended by 1, 2 index position, get appended by 1, 3 index position. Highest value knows or specifies when to stop recursion, because otherwise we get an infinite recursion loop and it becomes a whole lot messy for us. So that's all we need. Alright, it's an extremely simple algorithm. So let's just do linear search. Okay, so we need a list, we need a target, we need the high, and we need the counter. Here there's a key thing you need to understand. The counter will be equal to 0. The reason is obviously because the counting needs to start from the index position 0, right? Later when we do recursion, we'll change the default value like this. So we'll do plus 1. So for now, let it be like this. Here you might be wondering, how is high gonna help us? It's quite simple. If counter less than, or if high greater than or equal to counter, right? Only then it starts doing the recursion, otherwise it doesn't. So all we have, this is quite simple. I guess you guys can guess this. If list x counter, and this will just be equal to target, then we just do return index position of target of, let's do it like this, right? Str target present at, and then we do str middle. Oh no, wait, my bad. Str counter. Now this else statement is what is important, right? Here what we can do is, we can do return, right, linear search list x target high counter plus 1. This is key. Alright, as I said before, the counter will become appended. Now we can do print linear search list 1. Let's say target value for this list 1 to be 7, and then high would just be length of list 1 minus 1. Okay, let's try running this. Index position of 7 present at 6. So, or an index position of target value present at 6. So 0, 1, 2, 3, 4, 5, 6. That's correct. Actually, let me include a slash n here so it's neat. So here, let's try 8. Index position of 8 present at 7. So that's correct. Now you might be wondering, what is the enter value that isn't in here? None. So what we can do is, basically we can include a try except statement here, right? And then we do except return enter values within the list, right? So now, oh, that's interesting. I think this does the job for us. Yeah. Else return error. Yeah, I think that does the job for us. Yeah. Anyway, so that's linear search. Now you'll be wondering, how the hell do we implement this for lists? Let me show you. Or rather, strings. Let's take a string. I like coding with Python. Alright. Now let's remove the statement. Okay, print binary search. Alright, let's keep it like this. So first of all, what do we know? For strings, we can make substrings, or rather we can take these words, right, and split them apart, and we can add them to a list. The way we do this is quite simple. String equals string dot split. This will split it into its constituent parts, and then we need sorted strings. So what we do is string equals sorted and then string. Now if we print string, you guys will understand. Let's comment this. Coding I like Python with. It's arranged in alphabetical order, right? As you can see, C comes before I, comes before L, comes before P, comes before W. Now that we have that, we can implement binary search. So what do we know about binary search? Let's see. We need the target, we need a list, high, low, target. So the list in this case would just be string, obviously. So string. The high value, we need a high, right? String, high, low, target, yeah. So the high value in this case would be length of string -1. The low value would just be 0, and the target value, let's say, is coding. So let me quickly just comment this. Oops. Now if we execute the program, value search is present at index 0. As you can see, its coding is present at index 0. Let's try Python. Value search is present at index 3. 0, 1, 2, 3. That's true. Let's try width. Oh, it's getting. Yeah, okay. So value search present in index version 4, 0, 1, 2, 3, 4. So yeah, that's pretty simple, right? Let's try for linear search. Print linear search. In this case, we want list, target, height. That's it. So the list would be string. Target would be, let's say, like, and high would be length of string -1. Alright, let's execute this. Index position of like present at 2, 0, 1, 2. That's correct. Let's try coding. The same thing as before. Index position of coding present at 0. That's correct. So that's pretty much it. We have basically implemented linear search and linear search and binary search with Python. Let me quickly just add these requirements here, right? Okay, let me open a new private window and show you guys. Let me put in my paste bin. Alright, So let's take all this, Control C, Control V, syntax highlighting on, sure, why not, Python, paste expiration, never. Oh, sign in with Google. Isn't there an option where I don't have to do that? Currently not logged in. This means you cannot edit or delete anything. Oh yeah, binary / linear search with recursion. Yep, we got it. Alright, so let me quickly just copy this and share with you guys. It's in my description now. I think it should be there. Okay, so that's pretty much it. So I hope you guys enjoyed. If you did, what? Okay, that's weird. Some bot came into my chat. Anyway, if you guys enjoy, please make sure to leave a like and subscribe. And I'll see you guys later. See you. Bye bye.